So we just started talking about transactions, which are the activities that take place within a given database interaction session. Let's go further into transactions and really try to understand what they are. So we can define transactions as these atomic units of work. We'll talk a little bit more about what we mean by that, but they're units of work for the database to perform as a whole. Something that we often say is that relational databases in particular are transactional. What does that mean? What that means is that all changes to data are made through these units of work called transactions. A transaction captures either a single change or a multiple set of changes that we want to do to a database. Changes that we can do to data within a database are updates, inserts, and deletes. What's also important to note is that within a transaction, multiple changes are executed in an ordered sequence that we dictate to the transaction, and that an operation either succeeds altogether or fails altogether as a unit. So when we say that relational databases are transactional, we mean that all work that we ever do in a relational database is captured in one or more transactions, and that within a given transaction, that work is done with one or more update, delete, or insert statements that are bundled as a whole. So here's an example of the way in which we can add changes to a transaction. We can wound up using transaction.add and then in an ordered sequence add update, insert, or delete statements in some given order that we expect to queue up work within a given transaction. When we're done queuing up work within a transaction, we can then send off that set of changes to the database by executing a commit method that typically belongs on the transaction, which tells us to commit the entire set of work to the database to begin doing work on the database. So a transaction can have one or more update, insert, and delete statements that are all queued up together in some ordered sequence to be sent off to the database. The advantage of bundling work in this way is that if there's any particular point in the transaction where an update, insert, or delete statement fails to operate on the database, we can wound up rolling back the entire unit of work as a whole. And so a transaction can be cleared by using a command called rollback in order to clear the entire transaction out of it. Let's say that we had an update and then a delete statement, and we bundled both the update and the delete into the transaction. If the delete wound up failing, then doing a rollback will cause the delete to be rolled back as well as the update that happened behind it because it was all bundled within the same transaction. So why bundle work into transactions when we could instead just send update, delete, and insert statements directly to a database system? The problem is that database systems can fail, and we want the database to always be in a valid state. So if it makes sense that a given unit of work of multiple statements should only succeed if the entirety of it succeeds, bundling work into transactions will ensure that when any part of the transaction does fail, that our database is still in some sort of state that doesn't cause application failures down the line. If you're interested in the design reasons behind how transactions keep a database in an accurate, consistent, and durable state, go ahead and look into ACID properties. We'll link to resources from that outside of this video. So in review, databases are interacted with using client-server interactions, which take place over a network. Postgres uses TCP/IP in order to be interacted with, which is a connection-based communication protocol that we happen to use for the internet, and that we interact with databases like Postgres during sessions. Sessions have one or more transactions that then commit work to the database.